Today we're learning about equivalent fractions. Equivalent fractions. So we should be on page 169. Page 169 in your books. Alright, so in example 1, all we're doing is identifying equivalent fractions. This is very basic. This is basically, what we're talking about here is the concept behind what is an equivalent fraction. An equivalent fraction has the same part to whole relationship. What am I talking about when I say part to whole? The numerator is the part. The denominator represents the whole. How many parts are in a whole? Okay, that's what a fraction stands for. So, do these fractions have the same part to whole relationship? Yes. What do you think? How do you know? Justin?
Because 1/5 is having 2/10.
Very, very good, because 1/5 is basically the reduced form of 2/10. When you reduce them, they are the same fraction. Sorry, I'll go back. They are the same fraction. So I know that they are equivalent fractions because they have the same part to whole relationship. In example 2, this is more of what you would see on your homework assignment, okay? Writing equivalent fractions. If I had 6/8, okay, and I wanted to write an equivalent fraction, there's two ways that I could do that. I could multiply top and bottom, numerator and denominator, by the same number, okay? And it could be any number as long as it's the same top and bottom. Or I could divide it if it can be reduced. Can 6/8 be reduced?
Yep.
By what number?
2.
You can reduce it by 2. So let's first start off with multiplying it. So we're going to make it bigger, but we're going to create an equivalent fraction. Remember, whenever we're making it bigger, as long as we multiply top and bottom by the same number, it creates an equivalent fraction. So the 3/3, that's important. You must show this step on your homework tonight. You have to show me on your homework tonight what you multiplied or divided by to create your equivalent fraction. All right, now with 6/8, we just said that we could divide by 2 top and bottom to get a reduced form. And that would be, this is my answer right here. I box in my 2 equivalent fractions. So I've just written 2 equivalent fractions for 6/8. All right, so Justin just asked a good question. We do not need to box in our work, okay? You just need to box in your 2 equivalent fractions. So let's clarify that. All right. Okay, so that's how we would create equivalent fractions. Now, I want to, do I have another one in here? Yes. Okay, now I want you to go ahead and do this one on your own. Create 2 equivalent fractions for 10/12. Give me 2 equivalent fractions for 10/12. All right, somebody tell me, what did you multiply or divide by? Someone raise your hand and tell me. Chris?
3/3.
Okay, you multiplied by 3/3. Justin?
2/2.
2/2. I don't remember what I said, but all of those are fine. Did anybody divide? What did you divide by?
I did both.
Divide by what?
2.
Okay, 2/2. All right, so whatever you multiplied by, that's fine. Okay, so if you did 2/2 or 3/3, so you got 20/24 or 30/36, all of those are equivalent fractions. All right, now remember, you only divide when you can actually reduce the fraction. So we're going to do one more. What if you had, well, we'll do it at the end, okay? Let's go ahead and move on to example 3. All right, now in example 3, in example 3, we are simplifying fractions. Okay, so is there a number that can evenly go into 8 and 28? Yeah. Now, before you answer that, you want to think in terms of the biggest number. So this would be the greatest common factor. We're going back to 4.2 and making a connection here. What is the biggest number that would go into 8 and 28, Alicia? 4. It would be 4. So you could simplify, and yes, on your homework tonight, I do want you to show me what you divide by to get to the simplest form. Once we get past these sections, you can just do that part in your head, but I do want to see what you're dividing by to get the simplest form. Okay? And then when you divide top and bottom, you get 2/7. But how do you know that this is simplest form? How do you know that it's simplest form? Chris?
Because 2 is prime and 7 is prime.
Because 2 and 7 are both prime. Okay, that's one way to look at it. But sometimes numbers are in simplest form that aren't prime numbers. Okay, so let's think about that. We'll answer that in a second. So, all right, so let's look at B, 8/15. Can we reduce 8/15 by anything? Can we? Is there any number that goes into 8 and 15 both evenly? No. So I would say that 8/15 is already in simplest form. And what do I call two numbers whose only common factor is 1? Do you remember? What do I call them, Justin?
Relatively prime.
I call them relatively prime. All right, see the connection? I know that two numbers, even though they are not in and of themselves prime, because is 8 prime?
No.
Is 15 prime? No. But together, they're relatively prime because no other number besides 1 can go into them. Does that make sense? All right, so hopefully you see that connection there to our lesson yesterday. All right, so simplifying fractions, guys, divide top and bottom by the same number and reduce it to simplest form. Now, in example 4, we want to know, are these two fractions equivalent? Can you tell me right off the bat they're equivalent? Can you say, oh yeah, those are equal, or no, they're not equal? No. The first thing you need to do is reduce them to simplest form. All right, so how could we reduce 14 over 22? Worsay?
By reducing it by 2.
Very good. Divide by 2. Divide top and bottom by 2 and you get 7/11. All right, simplest form? Is that simplest form? Yes or no?
Yes.
Yes, it is. Okay, they're both prime numbers. There's nothing that goes into both of them evenly besides 1. All right, what about 10 over 25? What can I reduce that by?
5.
Vicky? 5. And I get 2 over 5. Same fraction? Are they equivalent? Is 7 over 11 equivalent to 2/5? No.
No.
It's the same. It has to be the same fraction in simplest form if they are actually going to be equivalent. So no, these fractions are not equivalent. Okay? On your homework for and you might want to go back and watch this video. On your homework on I forget what numbers it is. Numbers 28, 30, and 32. That's what you're doing there. Is you're reducing them to simplest form and telling whether they're equivalent or not. Okay? All right, if you understand that, that's everything you need to know for 4.3.